Yeah, I think we've got time. So there's one more thing that I want to talk through. So can I draw your attention to the screen for me? I'll try not to write too much on the board. Can I ask you to have a think about this? So can I have your attention for 5 more minutes, then we'll finish off. Okay, so can I ask you to think about this? At the moment, at the top of the screen, we have a probability distribution. In other words, an outcome and their associated probabilities. Now, what if I wanted to transform those outcomes? In other words, I said, well, actually, I got it wrong. Or what if I wanted to change the number of siblings they have so that everybody had 2 more siblings? Does that make sense? Okay. I want you to think how that would change the expectation. Because you've seen with this, if I think about what happens with the expectation when I transform the random variable, for example, if I add 2 to every single value in the random variable, okay, you can see that if I can think about expectations, I've also got variance as well. Does that make sense? Because variance is just really a set of expectations. Yeah? Okay. So have a think about this then. If I add 2 to every single number of siblings, so if I say everybody in here, whatever number of siblings you've got at the moment, you've now got 2 more. Okay? What would the expectation and the variance of that new distribution be? What do we reckon? Okay, good. So I'm basically saying here, I totally agree with you. The expectation of x plus 2 should be equal to what? So the old expectation plus 2. So the old expectation was like 0.92. If you add 2 to all of your variables, are you happy that the old expectation will just shift with it? What would the new variance be? Why would it be the same as the old one? Good, exactly. Because you're just simply sliding everything to the right by 2, are you happy that the spread doesn't change at all? So you've still got exactly the same spread. Variance is a measure of spread, regardless of where that's located. Okay? So you can see that illustrated on the screen. This is our old random variable, so 1, 2, 3, 4, 5. Okay? If I add 2 to every single variable, so there's the expectation and there's the variance. Okay? So the spread is represented by those pink arrows. Okay? If I add 2 to every single value, okay, then I would get this. Okay? So every single value moves to the right by 2. And are you happy that the expectation has moved to the right by 2, but the spread, those pink arrows, haven't changed at all? Is that clear? Yeah. Good. Fantastic. Okay. So what about then? What about if I multiply it by some value? So I now say, instead of having 1 sibling, you've now got 3 siblings. Or instead of having 2 siblings, you've now got 6 siblings. So everybody now has got 3 times the number of siblings. So E of 3x and variance of 3x. How would the expectation and the variance change? Okay. What about the variance? Interesting. You're right. You're right, but why is it 3 squared? Okay, so just because you know from previous experience. Yeah, good. Have a think about it like this. Here's my number line. Here are my random variables, 1, 2, 3, 4, 5. What I'm now doing is increasing it so it's moving to the right. Okay, so everything is now 3 times as far away from where it was before. Okay, so I'm making everything 3 times bigger. So there's my expectation, there's my variance. If I make it 3 times bigger, then my values are now going to be 3 times as spaced out. Does that make sense? Yeah? So think what's happened to my expectation. Well, it's now 3 times as far away from where it was before. Make sense? Yeah? So 3 times E of x, I agree with that. 3 times the old expectation. But think about my variance. My variance has also increased. Okay? Now my variance, remember, is the square of my standard deviation. So what I really mean here is that my standard deviation has been multiplied by 3. But because variance is the square of the standard deviation, it should be 3 squared as well.
So 3 is also squared.
Exactly. If I was talking about standard deviation, so I don't know, we don't really have one for standard deviation. But if I wanted the standard deviation of 3x, that would be 3 times the standard deviation of the old x. But because variance is the square of standard deviation, then the spread is also going to be squared as well. Does that make sense? Okay? So let me just repeat that. Standard deviation is going to be 3 times as far away from what it was before, because the spread is going to be increased by 3. But you remember that variance is equal to the standard deviation squared. Yeah? So therefore, if this gets increased by 3, the standard deviation gets increased by 3, the variance should be increased by 3 squared.